Hey, this is Mr. Mitchell with a video about reflection, diffraction, and refraction. Here are the questions, and here's the content. Now, reflection, diffraction, and refraction have to do with wave interactions. We've talked a lot about waves and how they expand, and the kind of waves that we've talked about before, the longitudinal waves and transverse waves. But what happens when these waves hit something or hit each other? And that's where you get wave interactions. Now, you probably can figure that these are the three main kind of wave interactions. The first interaction is going to be reflection. Reflection, and I think I will use this color, is, well, you can probably think of the word reflection like looking in a mirror. Whenever you have reflection, you have a bouncing back of a wave. And in fact, when you look in the mirror, the light waves bounce back at you. The reflection is the bouncing back of a wave when it meets a surface or a boundary. It does not have to be a mirror. If a wave hits, say, a wall, you do get some reverberation. You do get a reflection back of those sound waves. Well, you can have sunlight, for example, reflecting off a surface, and it bounces back. You also have something kind of interesting that happens. You may remember we talked about transverse waves, where you have somebody who has a rope and they lift it up and send the wave in one direction. Here's what happens. It's going to hit, well, in this case it's in a fixed position, and then the wave pretty much comes right back at you. So this is what happens when you have a fixed boundary. A wave looks exactly like the original wave whenever it is reflected. So the wave was sent this way, and once it hit the fixed position, then it came right back. Now, you may notice that there's a little bit of difference between this particular pair of diagrams and this one. You notice in this one that you have the wave that kind of comes back an up position as opposed to the down position. And really the only difference is going to be that here you have this rope, which is probably something that can go up and down. Maybe it's attached to a post or something like that. But believe it or not, the wave would actually go back upside down as opposed to right side up. But still, it looks almost exactly like the original wave as far as what is going out and what is coming back to you if you have something that is fixed. So if the wave hits something, it is reflection, and it will bounce back like the light bounces, like the rope bounces, or the wave bounces through the rope. Now, next is going to be diffraction. Diffraction is the bending of waves around an edge. When waves pass through a new opening or bend around an edge, they spread as if a new wave were created. And here's kind of the examples we have here. We have light, which is light or sound or any kind of wave, which ends up going through this narrow opening. What happens once it goes through the narrow opening? It's just like the wave began here, and it ends up going out just like it were beginning here. And here you can see you have a smaller opening. Same exact thing happens. It starts as if it is starting from that little small area right there and goes out. And you see another example of it right here. Now here it's talking about, or not talking, but it's like if it's bending around something. Remember, that's still diffraction. It starts right here just like it is a brand new wave, and it goes out just like a brand new wave would have from there. And you can see something to a smaller scale right here. So that is called diffraction. And finally, we have refraction. Now, refraction is the bending of waves as they pass from one medium to another. All waves are refracted when they pass through mediums at an angle, and the angle is the key. Notice we have the straw here. As you look at the straw as it goes down through here, there appears to be a disconnect. The straw doesn't appear to be continuing at the same angle. You see right here, once you get to this different medium, this bottom half of the straw appears to have moved to the right. And you know if you pull that straw out, it's not going to be in two pieces. This straw is one straw. It will, in reality, is going straight down through here. But when you have the different medium, we went from the air medium to the water medium, that is what happens with those waves. They appear to refract. I happen to fish a lot, and I know, and I happen to run across this. What you see when you see a fish in the water, you see it in a place where it really isn't. Here, as you look into the water, you see this fish. This is the image seen by the eye. It's actually a little higher up in the water column than where the fish actually is. What's happening here, you have two different mediums. Your eye, the sight is going, the light rays are going from the water to the air. So I've heard tell you, if you happen to have like a pistol or something, you were trying to shoot literally trying to shoot a fish in the water, then if you were to aim where it looks like it would be, you would miss it. If you had a bow and arrow, if you tried to aim where it looks like it would be, you would miss it. You would shoot right over it. And it's because of the refraction. The actual position of the fish is not where it appears to be just because of that refraction. Well, let's take a look at a different idea. Waves in the same place combine to produce a single wave. This is called interference, and you can see there are a couple of different kinds of interference. Now keep in mind, interference is when waves in the same place combine. So we're talking about two waves here. Notice this wave combined with this wave. I mean, maybe they end up meeting somehow. Notice what you have. The crests are lining up, the troughs are lining up, and so on. And notice the resulting wave has like double the size of the crest and double the size of the trough. If the crest and the trough meet up, that is called constructive interference. Whenever the waves meet, you actually end up with a higher wave, higher crest and higher trough, more amplitude than you did in the first place. That is constructive. Now, whenever you have two waves, sound waves, light waves, whatever waves, that do not line up, look here, you have the crest that lines up with the trough, and the trough that lines up with the crest, you end up with less wave than you did from the original ones, and that is called destructive. So let me remind you, constructive is when the crests overlap. The amplitude will be the sum of each wave's amplitude. Destructive is when the crest of one wave meets the trough of another. The result is a smaller amplitude than the largest of the two waves. Now, how does this apply to real life? Well, it applies in light waves and sound waves, and let me give you an example. The interference of light waves often produce a colorful display, and colors in oil, as you can see over here, and on soap bubbles are created due to the interference of light. No, there's not any pigment in these bubbles or in this oil which causes these color. The light that is coming in is going to have interference with the rays coming from it. And what's going to happen as you have kind of the interference here you're going to end up having these colors. The light is kind of broken up. So the light here actually comes from, the colors here actually comes from the light which is hitting it, and you kind of have a little interference, especially if it goes like through a bubble and ends up hitting on the other side. You have these light rays that have this interference from the bubble itself, and it produces some kind of refraction of these light waves. This is kind of like destructive interference. Same thing here. Now, how does it apply to sound? Here we have a person tuning a piano. You see the piano in the background. A person tuning a piano matches the waves of the piano string to his or her tuning fork. So he hits the fork, hears the hum, and he has to match the waves to that. He has to create the constructive interference, because if he matches the waves, he has the crest meeting the crest and the trough meeting the trough, and it is equal. But when it's out of tune, you'll probably have some destructive interference. It won't sound the same when he hits the key as he does whenever he has the tuning fork right there. So at that point of constructive interference is when the string is tuned. So when there's destructive interference, he needs to tune it more. When there's constructive interference, he's in good shape.